Okay, so we'll start today by looking at these two homework examples. Again, you can turn homework in late, so if you don't have it done for today, then turn it in Monday, and that's totally fine. But let's see if we can get people headed in the right direction, because I would like us to be able to graph things like these two right here. The first few examples in the homework, I realize now as I look at it, are different from the ones that we did in class in that they're supposed to be easier, but the 6-step process that we made up is for more complicated ones, and it doesn't really help as much on this kind of problem. Here's what we're going to do. We're just going to make a table, x and y, and I'm just going to pick -2 and -1 and 0 and 1 and 2. We're just going to fill in, and we're going to get 5 points in our table. Yes. How do I?
By looking at this, I'm thinking there's some magic formula we're supposed to know, but in reality, we're just supposed to.
You can make up any points that you want to. For me, these are my standard 5 points. If I'm not sure where to start, I start here. It could be this is not a good set of points. Like maybe the graph that we're going to come up with for those 5 points, maybe the graph looks like this. And really the action is all out here. It's not between -2 and 2, but really this is where things are happening. Okay, well, at least I'm starting someplace, and I'm just going to always start at -2 to 2. For the x squared minus 4x, that's more complicated. We're going to do our full 6-step process on that, but if you just don't know what to do, you're welcome to pick any numbers you want to. Those are my standard 5 points. So let's plug in, and if we plug in to our 1/2 x squared. So here we're doing 1/2, and I think we mentioned, it was Sam's suggestion, when do you put parentheses? Every time you see an x. Every x is inside of parentheses. That's the safe way to do it anyway. Just the x. So the 1/2 is sitting there waiting for you to do the exponent. How much is -2 squared? It's 4, and it's positive, right? Because x is in the parentheses, and that negative got squared to become a positive. So this one's equal to 2. And then we'll plug in -1. And so we go 1/2 times -1 squared. So I get 1/2 when I plug in -1. When you plug 0 in and you square it, you get 0, and then you do times 1/2, still 0. And then when I plug 1 in, it's going to be the same as the -1, because squaring -1 turns it into the same as squaring +1. So this is going to be 1/2, same as that number up there. And 2 squared is the same as a -2 squared, so this will be the same as that number. You don't need to do that shortcut. You can just do the calculations. It doesn't take that long. But when you make this table enough times, you start to recognize, oh, it's just going to be, there's a symmetry happening here. We can just copy other numbers. And so for this problem, I'm going to do nothing more and nothing less than just plot 5 points and connect the dots. That's it. 1, 2, 1, 2, 1, 2, and there's nothing down below. I'm just going to plot these 5 points. So the first one is at -2, 2. That's here. -1/2. Everybody see what we're doing here? X comma y. -1 and then 1/2 is maybe right there. 0, 0 is at the origin. And then you connect the dots with some smooth, continuous curve. Okay, thank you. Thanks. Thanks. Okay, and that's it. Now the directions for these ones, I it's my fault. I didn't mention anything about like wider. Well, we talked a little bit about wider and thinner and stuff. Yeah, how does it compare to the basic parabola? That's what it says. Yeah, so maybe I should have said more about this, but here's where we started yesterday. This green graph was our very first parabola that we drew, y equals x squared. And that right there is what the book is calling the standard parabola. That's the basic one for comparison purposes. Everything will be compared to this one. When I graphed negative x squared here in purple, how did it compare in terms of how wide it was? It was exactly the same. It was just copied upside down. But then we came down to these here, and maybe I didn't make as much of a connection as I should have. And quite frankly, the fact that the scales are different on that graph compared to this one makes it harder to make the comparison. But I will go ahead and draw the y equals x squared that was in green up there. I'm going to draw it in here. Let's see, 1 squared is 1, and 2 squared is 4, and 3 squared is 9. So that's up here. And then 1 is 1, 2 squared is 4, 3 squared is 9. So the green graph that's up there is the same as this green graph here. And now that we've got that green one there for comparison purposes, I should have made this connection last class, but here we can see, so the blue one is this guy, 3x squared. Would you say that is taller or shorter than the standard green parabola? And you might want to say narrower or wider. Which one? It feels like that blue one is narrower, right? Another way to think of it is that it's taller, because I could, for example, compare this point right here with this point right here and say, okay, this is this tall, but the other one is that tall. So it's taller than the other one. Either way is fine, taller or narrower. Blue one compared to the green. How about the red one compared to the green? You can say the red one is shorter. I can look at that point right there and say, oh, it's only this tall instead of the height of the green one there. Or you could say the red one is like a little bit wider than the green one. Both good ways to say it. And the equation of the red one is 0.5x squared. And so here's a fact. If you are looking at, I'll write here in green the equation for the green one. So the green one is just y equals x squared. That's our standard one. So if you are looking at y equals 3x squared, it's taller because that 3 is kind of a big number. But if you're looking at 0.5x squared, it's shorter because the 0.5 is a small number. And the cutoff for what distinguishes the big numbers, the tall ones, from the short numbers, the small ones, is 1, the one that's in front of the x squared. 1x squared is our standard. If it's any number bigger than 1, it's taller than the standard. If it's smaller than 1, it's shorter than the standard. Let's do this real quick. Okay, so you guys have played a little bit with GeoGebra. I want to make it bigger for you here. 1, 4, okay, and I also want to show the grid. Okay, so I'm going to graph y equals x squared. This will be our standard one for comparison purposes. And now we're going to graph y equals 3x squared, which we just saw. Because it's a 3, is it going to be taller or shorter than the standard? It's going to be taller because the 3 makes it 3 times as tall, actually. So I'll hit enter. You'll see that guy. Again, it's not to say that it's misleading, but you're welcome to see that the inner one, you're welcome to say it's narrower than the original. I prefer to think of it as taller, but you can say either one and be correct. Let me make this guy thicker just so that we can, where is it? Here. So the thick one is going to be our comparison one. So that thick one is the x squared. And then I can graph y equals, for example, 0.247 x squared. Personally, I have never looked at the graph of 0.247 x squared, but I can tell you for sure whether it's going to be taller or shorter than the original. It's going to be shorter. In fact, 0.247 as a percentage is what? Is about a quarter. It's 24.7%. That's what that number is down there. This graph we're about to see is going to be 24.7% as tall as the original, the thick one. And there it is. Again, it looks wider. You're welcome to see it that way. I see it as being shorter. Yeah. Yeah. So there's, you know, there's good stuff happening here. sliders are one of the best things in GeoGebra. I don't think we've talked about them at all, but I'll have this slider going between -5, whoopsies, cancel. That slider right now is going between -5 there and +5 here. And so what I'm going to do is type in, instead of y equals 3x squared or 0.25x squared, I'm going to type in y equals a times x squared. In this case, a is 1 at the moment, so it's just going to graph y equals x squared, which is already the thick one. But as soon as I bump this point a little bit to the right, a is going to get a little bit bigger. And what happens to the parabola when a is a little bigger? It's going to be narrower or equivalently taller. And so you're going to see it. It's really going to look like it's narrowing, if I'm being honest. So that innermost one right there is 5x squared right now. And then what's going to happen when I get down to some number less than 1? Now it's going to be under the thick one, right? Now it's 0. I don't see anything. What's going to happen when it's negative? It's going to be down. We saw the negative ones yesterday. And so there it's a very tall negative 1. You could have something that's a short negative 1. And I really do like this transition. It's kind of a smooth transition. You know, you would think that something being up above and something being down below are just really unrelated to each other, but it's kind of a smooth thing that happens in between. All right. So that is that. Let's look at a more standard kind of looking one, and that was this number 17 here. Okay, so the first step that we had in our process, I think, was the up or down question. And so in this case, we know that the A is the number or the letter we're using for the number in front of x squared, which is 1, which is positive. So is that an up or a down? Up, like it's positive, like it's smiling. So up. And then you'll have to remind me, was the second step to find the y-intercept? Y-intercept. And to find the y-intercept, you let a certain letter equal 0. It is x. In this case, what? Yeah, there is a nice little shortcut that Katrina is pointing out. We're going to plug the number in and then we'll see the shortcut. But when I replace those x's with zeros, again, I'm going to put the x's inside of parentheses. It's always safe to do that. So both those x's become 0. 0 there, 0 there. 0 squared is 0, minus 4 times 0 is 0, and everything is 0. So the y-intercept, how much is x? 0, that's the first thing we did. What did y turn out to be? 0, kind of a coincidence, that's the second thing we did. And then Katrina is pointing out that normally in here is a plus something, or minus. And whatever that number is always the y-intercept. You don't need to memorize it, but it works every time. And in this case, because there's no number, what is it? It's a 0. It's the only way we didn't have to write it. So that's the 0 that we ended up with here. Sam? In certain cases, but usually no. Like in this parabola here, the y-intercept at the origin was exactly where the line of symmetry is. It's not going to be the line of symmetry for this one. So, good question. Okay, part B is the y-intercept. I'm guessing C was the x-intercept. And to find the to find the x-intercept, what do we set? Y equals 0. So the equation up above was an x squared minus 4x, right? And instead of the y, we're now going to put 0. Now finding the x-intercept is invariably more work than finding the x-intercept. I said the same thing twice. Finding the x-intercept is more work than finding the y-intercept. Y-intercept, you just plug 0 in and you do arithmetic. Here, we need to do algebra. So almost always it's factoring. Yeah, like in a case like this where there's no plus number here at the end, it's going to look a little bit different than our standard factoring, which would be this kind of thing. In this case, we're going to say, oh, we can factor something out of x squared and 4x. Somebody we haven't heard from yet today. What can I take out of both of those? And then let's see if we can fill in what's missing. So I need to build an x squared. So what was in here? That must be x. I need to build a minus 4x. Minus 4 is there. That's right. And I'm going to put here in green a dot. It's multiplication. That was the point, is that now that it's multiplication, you can set each piece equal to 0. So we're going to split this right down the middle. Either the x is 0, that's the first one, or the x minus 4 is 0. That's the second one. Okay, here x equals 0 is done. There's nothing to solve. But over here, you need to add the 4 and get x equals 4. So that means that our two x-intercepts right, somebody else. So we have 0 is 0 for the first. 4 comma 0 is good for the second. X was 4, but y was 0. That was the first thing we did right there. Right, so for both of them, y is equal to 0 here and here. Dave.
Actually, the other way, I was going to plus 0 at the end, so I got x minus 4.
Yeah, so remember I had said that that it's going to look a little different than our standard parentheses, but you can do it just like Dave suggests. And one of the numbers will be 0, and that's perfectly okay. And you'll end up getting exactly the same answers. That's legitimate. Great. Okay, so we've got the x-intercepts. Oh, the next thing was to find the turning point down here at the bottom of this one. What is it called? The vertex. So we want to find the vertex. And I think this is step D for us. Find the vertex. And we do it by doing something to our two x-intercepts. What do we do with those two x-intercepts? We average them. We know the vertex is right smack dab in the middle. Okay, so our x-intercepts were x equals 0 and x equals 4. So we're averaging 0 and 4. The number right in the middle is 2. Even if it's not an easy number for you to see, you add them and divide by 2 every time. That's how we average the two numbers. So I'm writing an x to tell you it's the x coordinate, and then I'm putting the word vertex there just so we see it's a special x. Yeah. Okay, and then we just found part of the vertex, but we still need to find the y part of the vertex. So we know that the x is 2, but we don't yet know what the y is. So we need to find it. So let's find it. The original equation up there was x squared minus 4x, right? This is everything there is to know about the equation. What are those x's about to become? They're about to become 2's. We just figured out the x at the vertex is 2. So these guys in parentheses both become 2's. I forgot to give that back last time. Okay, so we go 4 minus 8 is negative 4. So that means that the vertex, somebody we haven't heard from yet, what's the x at the vertex? 2. What's the y at the vertex? Negative 4. Michelle, you with us on that step?
So far.
Okay. Dave?
Actually, another is possible 23. So something we gonna after class last.
During class, I'll come back and talk to you about that one. Okay. All right, so that is that. And then I think we're just about ready. I'm just going to draw my axes here. What are our numbers? Up to 4. Okay, so we're just going to start plotting these points. I think there's one other point we want to find, but I like to plot these ones first and then find the last point. Okay, the first thing we found was the Y-intercept. What was it? And I want you to give me 2 numbers because it's a point. So 0, 0, that was the Y-intercept. It's right there. Also happens to be one of the X-intercepts. What were the 2 X-intercepts? 0, 0, and 4, 0. So I'm plotting that point over there. That's the vertex. 2, negative 4. So we go 2, negative 4 is down here. Super. Call that V for vertex. And then we're supposed to find one more point, but this is kind of a special case. So Sam had asked about the line of symmetry. So in this case, it's right there at x equals 2, right? It goes through the vertex. And what we were supposed to do is find the point that corresponds to the y-intercept just on the other side of the line of symmetry. So if I go 2, then I better go another 2, but it's already there. So this one, we don't have another point to find. But we could find, if we wanted more points, we could pick any old x value that we want to. For example, x equals 1, right? X equals 1 is right there in the action. So let's just plug in x equals 1, just making up a number that's going to appear in my picture. So we're doing the same kind of calculation that we did right here in green, but instead of 2's, we're going to have 1's. So we do 1 squared minus 4 times 1. Same? Any number you want. The only downside is that if you pick a number that's not on the page, then you might not have a point that's useful to you. So I wouldn't pick 17 because that'll be way off in space here. Yeah, pick something that's on the picture you've drawn. Okay, so it should be 1 squared minus 4 times 1. Put those 1's in parentheses. So that's 1 minus, yeah, I want to do 1. Negative 1 would be perfectly good too. So I get negative 3. So 1, negative 3. That's a 4th point. There's nothing really special about that point. It's just more information for me. I picked x equals 1. I'm finding a point. It's at 1, negative 3. 1, negative 3 is here. If you picked x equals 17, you would find a point that's way out there, and it's a perfectly good point, just like 1, negative 3. And now we'll go ahead and do this symmetric thing. How far is it from here to here? 1, so then to find the next point, it's 1. So there's a point right there. And that's it. I've got 5 points. That's plenty. I'll connect the dots in a smooth curve. Oh, I don't know what I'm doing, as you can see. There's a lot of latitude in that part. And if you ever miss, like at the bottom, I didn't even touch the vertex, you just make it bigger. That's all. Okay, so it's good information for me. I've heard a lot of people say this homework was longer than usual, and that's not the goal. The goal is to make the homework about probably about 2 hours each night, just the homework, not reading, not doing the in-class activities, but just the homework. My goal is roughly 2 hours, and if I overshoot that, I like that information so I can fix it in future classes. All right, are these 2 good? Okay. So we're going to do something related but kind of different today. You can see well, this part at least looks similar. So we're on 46, so we can open to page 46 today. And while we're doing that, our very brief look at the calendar. Today and tomorrow we're going to talk about something called the quadratic formula. After today and, well, Monday, I should say, 2 days on the quadratic formula. That will be the end of the material for the quest. So the plan for the next week, today quadratic formula, Monday quadratic formula, Wednesday new material that isn't on the quest, Friday the quest, all right? Yeah, 1 week from today is our next quest. 1 week from today. What's happened? No, unfortunately. I know, we had those 3 snow days that just came in and ate everything up. I'll tell you what though, I'm happy to spend some time on this day. If we have questions heading into the test, we can spend some time on Wednesday, right? Sam?
Because all the snow days are we gonna...
There is a review day for the test. No more snow. Yeah. Okay, yeah, Tenzin. Shh. Can we have what? A cheat sheet. You may not have a cheat sheet. I have to ask my more experienced counterpart. Well, the good news is on this, okay, so I'll show you the worst formula of the whole semester. It's coming today, and it's right there. Yeah, so that right there is the worst formula of the whole semester. I will tell you that on the quest, 1 week from today, I will give you that formula on the actual paper, okay? So that's something. Okay. All right, so let's come back here and start at number 1. Can we go to Davis?
Examine the following graphs.
Okay, let's try the first one together, and then real quick, you can do the other 3 with your neighbors. So graph A is the top left. Looking for x-intercepts, I'm just going to put dots on them. How many are there? 2. That is the number of x-intercepts. And then I want you to estimate the coordinates. So the one on the left, what does it look like? Is it 0, -6? -6, 0. Which one is it? -6, 0. Okay. And then it looks like 1 and 0. Fair enough. With your neighbors, do the same thing for B, C, and D. Okay, so for graph B, everyone agree it looks like 1 x-intercept at 2, 0? Okay, graph C is where things start to get a little bit messier. So I see 2 x-intercepts there and there, but here we're just going to have to ballpark what numbers they're at. Any thoughts? -3.5. Does that look like 1.5? To me, that doesn't look like it's in the middle. It looks like it's a little left of middle for me. So I'm going to call it 1.4, but already, I mean, it's not an exact science, right? We're just ballparking here. And so, okay, maybe the other one looks like it's in the middle, so we'll say about -3.50. Just guessing. And then graph D, yeah, graph D, how many x-intercepts? We have none of them, and then so the coordinates, well, there aren't any, so I put NA for not applicable. Okay, so those are the different possibilities for parabolas. They can hit the x-axis twice or once or not at all. And it could be that the numbers are nice, like in part A, or it could be the numbers are not so nice, like in part C. All right, let's go to the next page. We're going to explore graph A in a little more detail. So number 2, Katrina. Okay, we've seen all the different cases. Could be at most how many? Could be 2, could only be 1, could be 0. There's no way it could have 3. That's it. Now let's go to Dan in the back for 3. Okay, so I'm giving you new information. All I did before was give you the graph, but now I'm telling you, and you can see I made it in GeoGebra. I'm telling you this is what I typed into GeoGebra to get that graph, all right? Okay, the two x-intercepts, we've already written them. Let's write them again over here. What's the first one? -6, 0. And then it looks like over there, 1, 0. All right, now we're going to answer two questions. We're going to keep getting the same answer every time, but I just want us to think about how the questions are different, even though the answers are going to be the same. So here it says, use the graph, identify the solutions to the equation 0 equals x squared plus 5x minus 6. So the only difference between this guy and this guy is that instead of a y, we now have a 0, right? So apparently, we're thinking about that graph, but specifically where the y coordinate is 0. Okay, so if I'm just looking at the graph and I want to think about where the y coordinate is 0, well, the y coordinate is 0 every place on that line, right? Y is equal to 0 everywhere there. So where will I find the parabola hitting that red line? Yeah, I'll find it right there at that point, and I'll find it right there at that point. The same x-intercepts that we found before. And so let's write down what the answers are to this equation. Here's the equation, 0 equals x squared plus 5x minus 6. The answers are just x's. There's no y's in that equation. So how much is x at the left point? Is -6. And how much is x at the right point? Is 1. So those right there are two solutions. Right? Certainly very much related to the question about x-intercepts from up above, but technically, this problem doesn't reference x-intercepts at all. Right? It just says find solutions to this equation. Okay, now let's think about how we would find these solutions algebraically. So I'm going to copy this equation again down below. 0 equals x squared plus 5x minus 6. It's already equal to 0, so that's a good thing for us. We're now ready to do what to that? Factor. So do the product sum. Take 30 seconds with your neighbors. See if you guys can come up with the factored form of this. All right, everybody okay with the factorization? X plus 6, x minus 1. And then we set each piece equal to 0. We get -6. Get x equals -6 and x equals 1. There. I said to you we were going to answer 3 different questions and keep getting the same answer. So of course, yes, we got the same x equals -6 and x equals 1. But I just want to highlight how we did these things differently. For this problem, whoopsies. For this problem, it said use the graph. We looked at the graph. We said, okay, 0, that's the red line. This guy right here is representing the parabola. We just want to know where they're equal to each other, and it happens at -6 and 1. There's no real like algebra per se. It's just like look at the picture and read off the answers. So we get -6 and -6 and +1. But if we didn't have the graph to look at, if we just had this equation, well, we can handle that. We can write the equation and then factor it and then do the algebra way. And of course, we get the same answers as the picture shows us, but it's a different approach to the same problem, right? Okay, so that worked out pretty well because we were able to factor the thing. Let's move on to question 4. We are back to Joe. Okay, so we've answered this already, but let's fill in the blanks again. Just ballparking. So what did we say before for the x-intercepts? -3.5, 0. And then the other one is, let me say 1.4. Okay, so that question specifically references x-intercepts. So we just read the graph and we find the x-intercepts. This next question says use the graph, identify the solutions to that equation. This is the same game we had before. Instead of a y equals, we now have 0 equals. But it's the same equation as that one right there, just the y has become a 0. So what can I draw here to represent the place where y is equal to 0? Where are all the places where y is equal to 0? Isn't it the x-axis? That's every point in the world where y is equal to 0. If we say, oh, we're just looking for places on the parabola that hit that red line, seems kind of funny. We're just going to put dots on exactly the same points that we found before. And now if I want solutions to this equation, what are they? We can estimate. So let's estimate. How much is the first x? Maybe negative 3.5. And x equals 1.4. Okay, so here's the bad news. Is when it comes down here and it says, how can we find these solutions algebraically? So I'll copy my equation again. 0 equals x squared plus 2x minus 5. How did we solve this problem a minute ago? We factored, right? So try factoring. Product sum. You can with decimals. Yeah, so we need two numbers that multiply to -5 and add up to +2. No such numbers exist for us, right? So the thing breaks down. So that's the bad news. The good news is that even though we can't find the solutions by factoring, there is a way that we can solve that equation. And it's the quadratic formula. It's this thing right here. So here's what it says in all of its glory. Quadratic equation written in the form ax squared plus bx plus c equals 0, always 0, has solutions, and then there she is. X equals -b plus or minus square root of b squared minus 4ac divided by 2a. Some of you know this already. Raise your hand if you could recite that without looking at it. So a couple, just a couple. Okay, so let's see if we can use that formula. It looks intimidating when you first see it, but let's give it a shot. So up here, we'll get a reader. Can we go to Michelle for 8? Yeah, I skipped. Thank you. Okay, so here we go. That's the equation that we just we ran into the wall with a moment ago. We can't factor it, so we don't know what to do. So using the quadratic formula is a 3-step process. Shh, Davis and Katrina. It's a 3-step process. Step 1 is put the equation in standard form, which means 0 on one side, and write them in this order. It's already in standard form. X squared plus 2x minus 5, 0, perfect. Step 2 is identify and write down the values of a, b, and c. Now, to be honest, with some practice, you really don't need to do this, but this is our first go at this, so we're going to be very detailed as we write down the a and the b and the c. A is always the number touching the x squared. What is it? It's 1. B is always the number touching the x. It's 2. I'll circle it in purple. +2. Yeah, maybe we should be consistent. We'll keep putting the signs in. C is the number that's by itself. It's -5. Yeah, so maybe I like Joe's idea there, or sorry, Sam's idea to say positive when it's positive, because if it's negative, we better include that. Are there any questions on where we got 1, 2, and -5? Okay, now the fun part. We have to plug into this equation. So there it is again, -b plus or minus all that stuff. So we're just going to write down piece by piece. We'll do this together. -b is the opposite of this 2 right here. So we'll put -2 plus or minus square root of. We'll talk about how to handle the plus or minus. B squared. I always am going to put that in parentheses. Every time I get to that b squared, I'm putting it in parentheses. So how much is b? Are we calculating or are we texting? What are we doing here?
Oh, calculating.
Okay, good. Okay, so b we said was 2, so that 2 is going to get squared. Minus 4 times a times c. 1 times -5. Divide by 2a. 2 times a. 1. Maybe I should have said I'm going to put parentheses around everything. Every letter can have parentheses. Every a, b, and c in the formula, if you put it in parentheses, you won't go wrong. Okay, so we're going to go further with this, but are there any questions on this problem so far? Okay, now the fact is, if you are not careful, it is very easy to make a mistake when you type in something this complicated into your calculator. So I will show you how to type it into the calculator correctly, but I will also tell you that if you go piece by piece, it might be more accurate, just a tiny bit slower, but more accurate than trying to do it all in one fell swoop. So let's go piece by piece, and then I'll show you the calculator way. So that's a -2. I won't write the parentheses anymore. Plus or minus square root of. Inside of here, the first thing I need to do, order of operations, is exponent, right? So that 2 is going to get squared and become a 4. Now I'm going to do the next step right here. Multiplication is going to come before a subtraction. So I'm doing 4 times 1 times -5. 4 times 1 times -5 is -20, but there's a subtraction in front, so it's actually going to become a +20. 4 times 1 times -5 with an extra negative in the front. On the bottom, 2 times 1, 2. -2 plus or minus square root of 24. Divide by 2. Any questions so far? Yeah. We're going to need to divide both parts on top by 2. That 2 on the bottom is underneath the 24, the decimal that you're talking about, but it's also under the -2. So we do have to be careful about that. Yeah, that's what we're going to do. Okay, so there's more to do about this one, but let me just, I promised a calculator thing, so let's do the calculator thing here. What you can do on the calculator is this thing just underneath the radical. So for example, I can type in 2 squared, and then -4 times 1 times -5. -4 times 1, and type in parentheses, just like I did on the, when I wrote it. So that should give me the same 24 that we got here. I would not do any more pieces to this problem than that. I would not try to type the entire thing in one fell swoop. It's possible to do correctly. It's more likely to do incorrectly. So that's how I would do it there. I did not mean to type that. So, okay, let's undo that. All right. Okay, so we are here, and then the other thing I was going to show was on this calculator, same idea with the parentheses and all. So I've got my 2 in parentheses, I hit my squared button, which is here, -4, parentheses 1, parentheses, -5. Where's my negative button here? Yeah, where's the plus or minus button? Oh, there it goes right there. There we go. Okay, apparently I don't know how to type it in on this calculator. What happened? We did 2. What did we do? There's 2 squared, and then we subtract 4 times parentheses 1 times parentheses 5 with a negative, close parentheses, square root. What happened to the 4? You know what? some calculators are stupid and they're intentionally programmed. Like people programming the calculators know better than to make it so it doesn't follow the order of operations. And that's what this calculator has been programmed to not follow the order of operations. Yeah, don't do that. All right. Okay. So let's see. So there's still a little bit more to do with this one. So do you guys remember we talked about simplifying things like the square root of 24? So even though, as Melanie points out, it's a decimal, we still can simplify it by breaking it down into the product, one number that's nice and one number that is whatever. We do. If we're going to try to simplify this, the black expression as far as possible, we need to go further here. So 24 is really what times what? It's really 4 times 6. It's also 2 times 12, but neither 2 nor 12 is nice inside of a square root. But 4 is very nice, so that's why we choose this. And then we had that wonderful property that said that it's equal to the product of the two radicals. And what is the square root of 4? 2, and then times the square root of 6, which we can't go any further with. Yeah, so I just did this on the side here, so I'm going to come back, Katrina, and I'll put the 2 in here in black. So -2 plus or minus, and then instead of the square root of 24, we just figured out it's really 2 radical 6. Everybody see it? The square root of 24 became 2 root 6. And it's not our final answer. Melanie. We can as long as we're careful. It's not quite that. Yeah. Our job is to split this up into 2 fractions. Before you cancel anything, it's very tempting. There are a lot of 2's up here. We're going to split it into 2 fractions. We've done this before. Here's what it looks like. Each of these fractions has a 2 in the bottom. It's really just a matter of splitting it up into 2 fractions. The first thing we said was -2. The other thing is that 2 root 6. You guys remember splitting fractions up like that? Right, and that's why you got to be careful when you cancel, because it's real easy to cancel the 2 on the bottom with one of the 2's upstairs. It turns out it cancels with both. And that's why I like to split it up every time. Okay, so this right here, gang, is our answer. -1 plus or minus the square root of 6. Yeah, and it's not clear what that has to do with the picture that we started with. So let's come back to reality. -1, yeah. -1 plus or minus, -1 plus or minus square root of 6 means 2 things. I'm going to write it as 2 things. Here's what it means. It means -1 plus the square root of 6, and it also means -1 minus the square root of 6. So it's really 2 completely different numbers, which is good because we've been after 2 x-intercepts this whole time. So those are the 2 numbers. If we type this into the calculator, so I'll do it here. Yeah. Okay, so if I type in -1 plus the square root of 6, get that. Yeah. And that 1.4, roughly, is one of the estimates that we made. Not nice for a Friday. It wouldn't have been a Friday, but the snow days made it a Friday. Yeah, Glenn. So let's be clear about exactly what I want. On the quest coming up, a week from today, we'll have our quest. I think I'm going to ask you to tell me the answer as a radical, which would be this stuff in blue here, the -1 plus root 6, -1 minus root 6, And then I also want to make sure you can type it in and get a decimal, so I will ask for that as well. So I want to see both. So then I'll put up here, this one was roughly 1.449, and this one was roughly negative 3.449. Typing those two into the calculator. Yes. Don't use a stupid calculator.
You know, each individual piece, it isn't bad. It's like, I find myself going, what am I using?
Yeah, it's a lot of steps. But I appreciate what you're saying. The steps themselves are not complicated in and of themselves, but when you throw enough of them together, it's a big process that we're trying to work our way through. Yeah. Okay, so let's do this. So we took some time at the start of class today to look at some of the homework from last night. And I don't want to try to rush through this, and I don't want to shortchange the class in terms of having time to practice these. So how about we're going to plan on, let's just start doing these here, but we'll do it in our groups, and then we'll spend a little bit of time at the start of next class just finishing this stuff. But see if you can work through. You know what? Why don't we jump it to the group activity, because that has answers. So go ahead and turn the page and see if you guys can get through parts A through D. Yes.
Square root of 32.
Mhm.
You could do 16 and then 4 and 4. And then
You're doing 16 and what to give you 32?
Oh, 2.
Yes.
Oh,